Hello everyone, so now we are going to do the OSPF packet type. We need to remember in OSPF we have the 5 packets. Okay, OSPF is having the 5 packets. We need to remember sequence wise. First packet is hello packet, second packet is DBD, database description, third packet is a link state request LSR, fourth packet is a link state update LSU. Okay, and fifth one is a link state acknowledgement. So in interview they will ask you what is the OSPF packets and how many. So we need to remember we have 5 OSPF packets and you need to remember the sequence. First one is hello, second one is DBD, database description packet, third one is a link state request, fourth one is a link state update, fifth one is a link state acknowledgement. We need to remember these packets we have. Now after that we need to remember this packet is what this packet is doing, what this packet is doing, what this one, why we have this packet, when we have this packet. This all information we need to remember also. So what we will do, first thing we need to remember OSP is having the 5 packets and name of the packet. In the sequence we need to remember first one is hello, second is a DBD, third one is LSR, fourth one is LSU, fifth one is acknowledge, link state acknowledge. Okay, so now we will discuss hello packet. What is the use for hello packet? Hello packet is used to discover neighbor. When we take the here let me show you, when we take the 2 router, here we have so many, but example if we have 2 router, when we connect this 2 router and when we start the when we configure the router OSPF here, if I configure OSPF here, okay, and OSPF here, we have the hello packet. This guy will send the hello to this guy will say to hello to this guy. If you remember, every 10 seconds they are going to send the hello packet. Dead timer is 40 seconds. In our first class we discussed that one. OSPF first class we are saying OSPF is having hello timer and dead timer. OSPF is having the hello timer and dead timer. Every 10 seconds OSPF is going to send the hello packet, and the other guy, example this guy send the hello packet to this guy. Every 10 seconds he is going to send. He will wait till 40 seconds. If he did not get the reply from this guy, he will remove his detail from his database. He will remove this router information from his routing table. He will imagine this guy is dead, no more available, he is not sending the hello. So whenever we take the 2 router and whenever we connected the 2 router, whenever we activate the OSPF, this guy starts sending the packet, OSPF packets they are going to send. First packet they will send to discover neighbor. He will say hello to check the router which is connected to me, he is also having OSPF or not. If this guy also having the OSPF, he will reply hello, and they will become neighbor. They become neighbor. So what we can say? We can say hello packet is used to become neighbor, to discover the neighbor. Hello packet is used to discover the neighbor, to build the neighbor adjacency and maintain them. And then we have the another packet, that is DBD. Okay, DBD. This packet is used to check if the LSDB between the 2 router is same or not. If I give you simple example, what we will have like we have one router here, this is a R1, and we have another router here R2. We configure the OSPF in this interface and this interface, all the interface whatever is connected to this, all here and here also. So he will say hello to this guy, okay, and this guy will say hello to this guy. Hello packet is used to discover neighbor. They both become neighbor, okay, they both become neighbor. These 2 guys become neighbor, then they will start sending the DBD, database description. Database description they are going to send. What is the meaning of database description? Means they are going to send the information about the prefix, whatever the network interface, whatever interface they have, whatever information they know about the network, other network, they will share that one. So what we can say, they will send the DBD. If you see here, they will send the DBD. Why we use the DBD? To compare whatever information we are sending, that guy is having or not. Whatever information we are sending, example this guy is saying, R1 is saying I know 1.1.1.1, okay, and I know 2.2.2.2. I know 3.3.3.3. This interface is connected to him directly. Okay, so R1 is updating. R1 is saying that I have this information in the DBD, and this guy also sending some information. Maybe he has some other network here, something other network like 10.10.10.10 or 20.20.20.20 something. So this guy will send DBD to this guy will send to this guy, and they will compare. Okay, they will compare. What they will check? They will check, do we have this information or not? In which packet they will do this one? In the DBD, database description packet. So what we are saying, first when we connect the two router and when we configure the OSPF, first packet they will send, they will say hello, and this guy also say hello, and they become neighbor. When they become neighbor, they will share the information. Like same thing, if you go anywhere, if you see anyone is staying near your home, you will say hello, that guy will say hello, then you will start talking, you are working here, your office is here, that guy will say something, both will talk each other. Same thing here, they will share the information. They will share the information about the DBD, whatever information, whatever network he know R1, he is going to tell to R2. Whatever R2 know, he will tell to R1. So in the DBD, what we can say, this packet is used to check LSDB, that is link state database, between these two router is same or not. Means this guy and this guy, both guy know same information or not. Means R1, whatever R1 know, R2 is know that one or not. This packet is check that one. After that, example, R1 is not having the information of this one, 20.20.20. So what R1 will do? He will send another packet, that is nothing but LSR, link state request. So R1 will say, R2, can you give me the detail of 20.20.20, because I don't have this information in my database. That packet is LSR. Then this guy will reply and he will give that information, that is LSU, link state update. And then this guy receive that one, he will acknowledge. He will say, I receive what information you send, that is link state acknowledgement. So these are the 5 packets. Okay, what is the packet? I will show you. Let me zoom in this one so you can see clearly more. Okay, so what we are saying, hello packet to discover the neighbor, build the neighborship, okay, and maintain them. Second one, DBD is a summary of the LSDB. Here we will check whatever database I have, all information you know or not, both are going to check. If anything is missing, the guy who is not having information, he is going to ask the other guy. He is saying, can you give me this information? He is saying link state request. Link state request is used to get the information from the neighbor. And neighbor, if neighbor is sending that information, he is going to send in the form of LSU. He is going to send link state update. This is like envelope, it is having the multiple LSA. Example, if R1 don't know so many information about R2 network, so he will request from him like 20.30.40. All networks. So he will send one LSU. In that one you have LSA, all the link state information, and that will come here to R1. When he receive, he will acknowledge, he will say, yes, R2, I received that one. Okay, I received that one, they will say. So we can check these packets. Via sharp we can verify that one. Okay, and this is important point, you need to remember this one also. OSPF use his own protocol like EIGRP. EIGRP later we will do. So EIGRP, OSPF is not using TCP or UDP. They have own protocol, and that protocol number is 89. OSPF protocol number is 89 for all its packet. In interview you will get the question, what is the OSPF is using which protocol. OSPF is not using TCP or UDP. OSPF is having his own protocol number, that is 89, and it is having the 5 packet: hello packet, DBD, LSR, LSU, LAC. Hello to discover neighbor, DBD to check what information my neighbor is having, I also having that all information or not. If not, I will request, neighbor will send, and I will acknowledge. So we need to remember this packet, what is the meaning of this packet, and in the sequence. Okay, we need to remember in the sequence. So now I will show you that packets. So we have already here. So let me open this. See how I am opening. Just go here and right click. Here is a start capture. When we say start capture, he will capture the packet what is going on in between R3 and R1. Okay, in between R3 R1 whatever is going on, it will show. So what I will do, I want to check only for the OSPF, not all. So I will write OSPF. I will select the OSPF here and then I will click this one. Okay, so if you see, we are getting the OSPF packet. Both guys are sending the hello. Okay, this is the 200.1.1.1 guy is saying hello, and the other guy 200.1.1.2 is saying hello. One is saying hello, two is saying hello. Who is one, who is two? Let me show you. Okay, where we are checking? We are checking between the R3 and R1. We are checking between the R3 and R1. So R3 IP is 200.1.1.2 and R1 IP is 200.1.1.1. So this one router is saying hello to 2 and 2 router is saying hello to 1. Okay, one by one they are sending. They are sending through this one. This is a multicast address. If you remember, in our starting class we told 224.0.0.5 is used to send the hello, and 224.0.0.6 is used to send the information to DR and BDR. We are going to see the DR and BDR in the classes, coming classes, next topic. But now just remember these two multicast IP we are using in the OSPF. This one is to send the hello packets. This one is used to send the information to DR. So if you see, they are sending the hello. Both guys are sending the hello to each other. This guy R1 is saying hello. This 202 means R3. R1 is saying hello to R1, R2, R3, and R3 is saying hello to R1. Like this they are sending hello. So if I catch any packet, let me take any one packet. I will take this one packet. What I have here, this one, if I open here, we have OSPF header. Okay, if I open OSPF header, what information I am getting here? I have, this is a version 2. Okay, in the hello packet, inside hello packet, what information we have? Both guys are sending hello message. So inside hello, what information I have? I am using the version 2. OSPF version 2 I am using. Version 2 means we have two version in the OSPF, version 2 and version 3. Version 2 means if you are configuring the OSPF by using the IPv4, that is nothing but version 2. If we are configuring the OSPF by using the IPv6 means version 3. So first information what we get, we have the version, and this one is a message type is hello packet. This is a hello packet, and what is the number of hello packet? 1. If you remember, I told just now we need to remember in the sequence. This is a 1. 1 means hello packet. So in that one what we are getting, we have the hello packet in the number 1, and packet length is 48. And if you see, source OSPF router, who is sending that router IP address, and area, which area we are using? Area ID, we are using area 0. Area 0 also we can write in this form also, like 0.0.0, like this also we can write. And is there any error? Nothing, everything is good. Did we use any authentication? We did not use any authentication. If we put any password, it will show us we are using some password. Okay, so this is the header. This is the header only. OSPF header is having this information, and then we will open the OSPF hello packet. Now I open the OSPF hello packet. So what is present in the OSPF hello packet? I have the network mask, that is subnet mask, and I have the hello timer. As we told, hello timer is 10 seconds. So we have the hello timer, and we have the router priority. By default, all the Cisco router is having the priority 1 when we configure the OSPF. So this is a priority. And what is a dead timer? We have the dead timer 40 seconds. And the who is designated router, that IP address. Who is backup designated router, that IP address. Who is neighbor, that router ID. So this information is present in the packet. Let me repeat again. No need to worry. We are going to discuss this again later also. So just observe, we capture the packet in between two router. We have one router here, we have another router here, we have R1 and R3. They are sending hello every 10 seconds. Okay. So we capture one packet and we open that one. When we check, we have the packet header. Example, we capture one packet, it is having the header here. That is OSPF header. And here this is a first packet, hello packet, like this. This is a header and this is a hello packet. So in header, what information we have? In header we have version 2 we are using, and we have this packet 1, and what is the length of the packet, and who is sending, and in which area we have, and is there any error, if we are using any password, this information present in the header. Then we have the hello packet. Hello packet is having the network mask, that is subnet mask, hello interval he has, dead interval he has, priority of the router he has, designated router ID and backup designated router ID, and we can say the active neighbor, that is neighbor router ID. We have this information here, okay, in the packet. Now we are saying we have 5 packets, but we can see only one packet here. If you see, only one packet is going. If you see, this is only hello packet, but we have total, how many packets we have? Total we have 5 packets. As per our theory, we have 5 packets, but now if you see, we can see only one packet. Always every 10 seconds only one packet is going here. So what we told, when they become neighbor, they will say hello and they become neighbor. After that they will do what they will do, they will DBD, they will exchange the database. So they already exchange. After that, whatever is missing, they will request link state request, LSR, LSU, and then LSAC. They already perform this. That's why we cannot see that information here. Okay, that's why we cannot see that information. So what we can do, we can restart the router to see this one, or we can make some changes in the network, so they will again change this information. We can do some operations, so they will we can see the different packets here, other packets. Okay, so what we are saying, hello packets, they discover neighbor. Even they discover neighbor, they will send hello continuously. They are sending every 10 seconds to make the urgency, means to make the neighbor, to keep them neighbor. Let me show you here, this one. Build the neighborship and maintain them. To maintain them also, they are sending hello every 10 seconds. So now what I will do, I can keep the Wireshark like this only. Okay, it is running. I will go to this router R1. Okay, I will save the configuration whatever I have, and in the R3 also I will save the configuration whatever I have. I will restart this router both. Okay, so we can capture the packets whatever they are doing. Whatever they are doing, we can capture the packet. So let me switch off this router R1. I can reload also, just to show you about the different packets. I can start here also, I can start. Okay, I start both router, and if you see here R3 and here is R1. Okay, we started the R3 R1, and now we can capture in the Wireshark. Okay, we can capture here in the Wireshark what packets we are getting. Hello packets stop or still going on. They stop and then again they started, I think. Yes, they started now or not yet. Let me check here, and here now we will have the hello packet. Yeah, we will see here the other packets also. We need to wait. They will form the neighborship. They will have the different packets. We need to wait. Still it is not go. We need to wait. Okay, so let's see here they form the neighborship or not. We are checking between the R1 and which router we are checking, R1 and R3. We restart R1 and R3 only, right? Yeah, this one we restart, and no, actually we did not restart the R2. Okay, R3, R1 and R3 we are checking. So we will have here, it should show you, but still it is not come here. We will wait. We should have here. We miss or what? Let's see neighborship form or not. between the R1 and R. If I write here show IP root, we are having the root, show IP OSPF neighbor, we have the neighbor also. So now we should get some information here. Here we should have the packets, or if we are not getting packet, we can do one more thing. We can make one interface down and make again up, so we can get that information also. But generally we have here all the packets, 5 packets. Whenever they are forming the neighbor, they will do that one, but here it is not showing. Maybe this Wiresharp is having some issue. Anyhow, what I will do, I will restart one interface. I will make down and up. Which interface? Let me see here. I will make this interface maybe F0 by 0. Okay, this interface I will do, so this update will go here. So let me go to the R1 F0 by 0. So I will go to the R1 here and I will make interface F0 by 0. I will make this shut. Okay, so now link will go down, so this update will go here also. So we will get some information here. If we are not getting here, means we need to close the Wiresharp and open again. It should come here. We should get the packets here. We make one interface down and we make again up, but still it is not showing. Or let me capture other. Why here it is not showing? Let me close and open again. Let me close and open again. Maybe some issue with that one. Open again. And see here, if you see hello packet, let me put OSPF, and here I will select hello packets are coming. Now let me make this one no shut. Just now I put shut, so I will put no shut. Let's see we have anything here. Yeah, even now it is coming. Maybe that time it is hang, that's why it is not showing, but now it is showing. Okay, so if you see here, all the packets are coming. Okay, let's see here what we are getting here. This black color, these both guys are saying hello hello. This guy and this guy both are saying hello hello, and they become neighbor. And when they become neighbor, this guy, someone requested this art 200.1.1 share the information, LSU he sent, and other guy acknowledge, he received that one. And if you see here, this guy is sending the LSU, because LSU will be, maybe if we have the big database, he will send the small packets. So 1 2 3 4 5 times they are sending LSU. This guy is sending, acknowledging. This guy, if you see 1.2, this guy is acknowledging, this guy is sending, 1.1 is sending, other guy is acknowledging. This all information they are sending. So what packets we can see here, and let's open the packet. This is a, if you see here, LSU, this packet. If you open here, what we have, this is a packet 4. LSU is nothing but, in header we can check, this is a LSU, this is a packet 4. The router ID is this one, area is this one, and we don't have any authentication. And if we see here, we have information here, that is a router length we have here, and here this is the router ID, advertise route we have here, what route they are advertising, that route. So example, what I will do, I will make any other interface down here. Let me look here. I will make this interface no shut, and then I will make again no shut. So when I put the shut, one guy send the update, okay, saying that this interface go down. This guy 200.1.1.1 is sending to 200.1.1.2, means router R1. This is a router R1 is saying to R2. What he is saying, something he is saying, something he is updating, and the R2 is saying okay, I received that one. So what he is updating, he is updating that interface just now which we shut down. So if you see, he is updating. So if we capture this packet, this one, and if we see here, this is the packet, is update packet. And if we see here, we have here the Here we will have the which one go down, we have that information here. This is the route link ID is 2.2.2. that interface, the LSA, if you see here, sequence number they have, checksum value they have, and they have the link number 3. This link just now we make the down, that link go down, he is showing that one. The flag is LSA age is 1, external route, the router LSA, the router ID, and advertise route, checksum value here. We will have somewhere here information that route go down. Just now we make down, right? So that information will be present in this one. So they are updating that one. Somewhere we have here, maybe we are not saying here, somewhere we have that, saying that that route go down. And when we make up again, it will show that route come up. And if you see this one acknowledgement, this one, if we capture this route here, here we can see this is a LSA acknowledgement saying that this is a packet 5, and he acknowledged whatever that guy sent the update, I received that update. Link state, this is a 2.2. Yeah, link state he sent for 2.2.2. So who is 2.2.2? This router. This is the router ID. So he sent that information to this guy, and this guy is acknowledged that one. So that are the packets, different packets. This packet number we can see, this is a packet 5, as we told, this is a packet 5, and this will be the packet 4, this is a packet 4, and the other packets whatever DBD also we can see where we have the DBD, somewhere we have DBD, or when we make this interface down and up, let me make this interface in the R1 F1 by 0. I will go here to this interface F1 by 0. I will write here shut. I will make here shut, and then we will make again no shut. Okay, so let's see here what we are getting here. I will make again no shut this one. In the R1 which interface I done, F1 by 0. So now we can capture here what information we will get. Yeah, here if you see DBD, now we reset the OSPF in between two router, this router and this router directly connected, we are capturing here. So I make this interface down and I make up again. So here they are doing the process, same process, hello hello, then after that DBD exchange, they are exchanging the database, and then whatever is missing that guy is requesting link state request, they are exchanging the database. He requests this one, the other guy is updating that one, again the other guy is requesting, other guy is updating, requesting, and at last acknowledging that one. So these are the 5 packets. We need to remember whenever we make the neighborship between the two router, they have these 5 packets. First one is discover neighbor, and second packet is to compare the DBD database description, all are having the same information or not, whatever is missing R1 is going to request from R2, and same thing R2 is going to request from R1. Request is LSU, we are saying link state update is nothing but the guy, if R1 is requesting something, R2 is sending, that is known as LSU. If anyone is requesting, then we can say LSR. LSR means link state request, and the guy is replying LSU, and again we are acknowledging that one. So these are the packets we can capture with the Wireshark. So this is a OSPF packet. This is very important, we need to remember we have the 5 packets. I already put in our notes. So this one, this is a 5 packets we need to remember in the sequence, and we need to remember in high level what packet is for what purpose. Okay, what packet is doing what. If you remember this one, that is sufficient. In your own words you can reproduce that one. Okay, and here I captured that one, same thing just now what we saw in the Wireshark, same thing, hello packets, and then whatever is update. And if you want to check with debug commands also, we can check with the debug also, we can check. I can show you with the debug. Hello packets are going here. So how we can check? We can go in any router and we can enable the debug, but don't do in the production network. When we do the debug, CPU and RAM will go high for the router, so for that purpose we should not do the debug. But for the lab purpose we can do debug IP OSPF packets. Okay, debug IP OSPF packet, this is a command. So now we are going to get the packet, whatever packets they are sending. If you see here what we are getting here, OSPF 1 process ID, this is RCV. Okay, and now we can read this one. What we can say, we have the v2 means version 2. Okay, version 2, and t1 is nothing but OSPF packet number 1. This is a hello packet, so packet number 1. And after that what we have, L48 means the packet length is 48. And after that we have the RID means router ID. What is the router ID? 3.3.3. And after that AID means area is 0. Then we have CHC, checksum. We can see checksum, we don't have any error, so we have 508 checksum value. There is some checksum value, that one is saying everything is okay. Then we have authentication, we did not configure any authentication, so we will see 0. And awk also, this one is also saying the, if we enable the authentication we will have some value here, so we did not enable. So this way we can read the OSPF packet. What we are saying, we receive, this is a version 2, this is a, what we can say, t1 is nothing but packet number 1. If we have another packet number 2, we have 2 here, 3 here, like this. But now they are sending hello packets only, that's why it is coming only hello packets. If you see, I already write in the notes, this is the packets we are getting. This is, if we debug the IP OSPF packet, we can look like this. v2 means the version 2, t1 means the packet number, L48 is the length of the packet in bytes, and RID means router ID. Same thing as mentioned, area, this is a checksum. Packet is having any issue or everything is good, they will check that one. Authentication we did not configure, and this one, if we enable authentication, we will see some more information here in the awk, here in this place where we have the AUCK awk here. So this is a OSPF packets. With lab we verify also. So let me stop this recording.